Sine of 0 plus h minus sine of 0 can be written as, after simplification, this reduces to sine h divided by h. Suppose if y is equal to x square, then this is y dash or dy by dx is equal to 2x. So differentiation of x square is equal to 2x. The derivatives of a function f at any point x is defined by f dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the temple of excellence. Today in this session I am going to take very important concept, that is second part of the chapter, derivatives. So today I am going to discuss regarding derivatives. In that, first principles, how to differentiate a function using definition, or it is also called as the first principle method. Now let us know what is meant by derivatives and how to solve using first derivative method. Now suppose f is a real valued function and a is a point in its domain of the definition. Suppose if f is any real valued function and a is any point in its domain of its definition, then the derivative of f at a is defined by limit h tends to 0 of f of a plus h minus f of a divided by h. If this exists, provided this limit exists, then the derivative of f of x at a is denoted as f dash a. So therefore, the derivative of the function at x is equal to a is f dash of a is equal to limit x tends to 0 of f of a plus h minus f of a divided by h. If this limit exists, that is, the derivative of f at a is defined by f dash of a is equal to limit h tends to 0 of f of a plus h minus f of a divided by h. This is a definition for a derivative of a function. By knowing this, let us move on to a simple problem. Now, find the derivative of 99x at x is equal to 100. Now, by definition of the derivative, what is f dash a? F dash a is, we know that f dash of a is equal to limit h tends to 0 of f of a plus h minus f of a plus h minus f of a divided by h. Okay, this is the definition. Now, instead of a, let us take f dash of 100. So, what is to find is the derivative of 99x at x is equal to 100. That is, f dash of 100 is equal to limit h tends to 0 of f of, what is a? A is 100 plus h minus f of a, f of 100 divided by h. Okay. So, f dash of 100 is equal to f limit h tends to 0 of f of 100 plus h minus f of 100 divided by h. Now, what is the function given here? So, here f of x is equal to 99x. So, therefore, f dash 100 is equal to limit h tends to 0 99x, 99, x is nothing but 100 plus h, 99 into 100 plus h minus 99 into 100 divided by h. Okay. So, 99x. So, therefore, f dash of 100 is equal to limit h tends to 0 of 99 times 100 plus h minus 99 times 100 divided by h. Now, if you simplify, what happens? This is equal to limit h tends to 0, multiply it. So, 99 into 100 plus 99 times h minus 99 into 100 whole divided by h. Cancel the terms, these two gets cancels. Limit h tends to 0 of 99h divided by h. So, this is equal to h and h gets cancelled. What you will get? So, this is equal to 99. So, the answer for this is, so that is f dash of 100 is equal to 99. That's it. As usual, you know what is the derivative of x? X is 1. So, differentiation of 99x is 99 into 1 is 99. That's it. Very simple method. Let's move on to the similar type problem. Find the derivative of f of x is equal to sin x at x is equal to 0. Now, same as that of previous, the definition f dash a is equal to limit h tends to 0 of f of a plus h minus f of a divided by h. This is the definition. What is the function given? F of x is equal to sin x at x is equal to 0. So f dash of 0 is equal to limit h tends to 0 of f of a plus h. Now what is to find f dash of 0? So f dash of 0 is equal to limit h tends to 0 f of a 0 plus h minus f of 0 divided by h. Okay. Now since what is f of x? F of x is equal to sin h. So what is f of 0 plus h? F of 0 plus h can be written as sin of 0 plus h, and similarly f of 0 is equal to sin of 0. Substitute here. So this is limit h tends to 0, f of 0 plus h is sin 0 plus h minus f of 0 is sin 0 divided by h. Okay. So if you simplify, then this is equal to limit h tends to 0, sin of 0 plus h minus sin of 0 can be written as, after simplification, this reduces to sin h divided by h. So what is this equal to? Since you know there is one formula, limit theta tends to 0, sin theta by theta sandwich theorem, that is also equal to 1. So limit h tends to 0 of sin h by h is equal to 1. So the simplified answer is 1. That means the derivative of sin x at x is equal to 0 is 1. What is derivative of sin x? Cos x. What is cos 0? Sin 0, 0. Cos 0 is 1. That's it. Now move on to the next problem. Find the derivative at x is equal to 2 of the function f of x is equal to 3x. Same. So what is the definition? Limit f dash of a is equal to limit s tends to 0 f of a plus h minus f of a divided by h. So what is the function given? F of x is equal to 3x. At x is equal to 2 means f dash of 2 is equal to limit s tends to 0 of, what is f of this is nothing but f of, what is a here? 2 plus h minus f of 2 divided by h. Right. Now since what is f of x? F of x is equal to 3x. So f of 2 plus h can be written as 3 times 2 plus h minus, yes, into f of 2. F of 2 is equal to 3 times 2. Okay. Now apply the limit here. So therefore this becomes limit h tends to 0. F of 2 plus h is nothing but 3 times 2 plus h minus f of 2 is 3 into 2 divided by h. So what is this equal to? This is limit h tends to 0 multiplied 6 plus 3h minus 6 divided by h. This 2 gets cancelled. This is equal to limit h tends to 0, 3h divided by h, that's equal to 3. H gets cancelled, that's equal to, so derivative of this, so f dash of 2 is equal to 3. You know what is derivative of x? X is 1. So 3 into 1 is 3 itself. So therefore the derivative of the function f of x is equal to 3x at x is equal to 2 is 3. That's it. This is how we are going to differentiate the function using the method of definition. Right. Now let us discuss regarding first principle method. What is first principle method of a derivative of a function? Now the derivatives of a function f at any point x is defined by f dash of x is equal to limit h tends to 0 of f of x plus h minus f of x divided by h. So if this limit exists, then it is called as the derivative denoted as f dash of x. That is, sometimes this f dash of x is denoted as d by dx or f dash of x or dy by dx. So dy by dx can also be denoted as f dash of x, or sometimes this can also be denoted as y1. Right. So this is the first derivative of a function. That means the derivatives of a function f at any point x is defined by, what is the definition? Limit h tends to 0 of f of x plus h minus f of x by h. If this exists, then it is the derivative f dash of x denoted as f dash of x, or it is also denoted as dy by dx is equal to f dash x or y1, or dy by dx, d by dx of x, right, or d by dx of f of x. D by dx of f of x is nothing but f dash of x. Now move on to the first problem. Find the derivative of the following by first principles or by definition. Differentiate f of x is equal to 10x with respect to x using first principles. Now let, what is given? F of x is equal to 10x, right? Now f of x plus h is equal to 10 times x plus h. Now by definition, what is the definition? So that is f dash of x is equal to f dash x is equal to limit h tends to 0 of f of x plus h, f of x plus h minus f of x divided by h. So this is equal to limit h tends to 0, f of x plus h is 10 times x plus h minus f of x is 10x divided by h. Simplify this. This is equal to limit h tends to 0 of multiplied 10x plus 10h minus 10x divided by h. Minus 10x plus 10x gets cancelled. Limit h tends to 0, 10h divided by h. So 10h gets cancelled. This is equal to 10. So therefore, derivative of therefore f dash of x is equal to 10. That means therefore it is denoted as d by dx of 10x is equal to 10. That's it. So derivative of 10x is 10. Okay. Now move on to the next problem. Let us consider f of x is equal to x square. So what is the function given? Here given f of x is equal to x square. So according to the definition, what is the derivative? F dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. Right. Now since x is equal to f of x is equal to x square, therefore f of x plus h can be written as x plus h whole the square. So substitute here, that is limit h tends to 0 f of x plus h is x plus h whole square minus x square divided by h. So this is equal to limit h tends to 0. You can apply a plus b whole square formula for this. What is a plus b whole square? A square plus 2ab plus b square. So a square plus 2ab 2hx plus b square h square minus x square divided by h. So minus x square plus x square gets cancelled. What is left in the numerator? Limit h tends to 0 2hx plus h square divided by h. So this can also be written as, you can take the common factor. So if you take common factor, limit h tends to 0 of h is the common factor. What is left over is 2x plus 1h divided by h. H and h gets cancelled. You can apply the limit. So if you apply the limit for this, limit h tends to 0 2x plus h. So if h is equal to 0 means 2x plus 0, that is equal to 2x. So that means the derivative of the function, therefore d by dx of x square is equal to 2x. Derivative of x square is 2x. So that is, see, if f of x is equal to x square, then f of x plus h, f of x plus h can be written as x plus h whole the square. Now what is the definition? F dash of x is equal to limit h tends to 0 of f of x plus h minus f of x. That is f of x plus h is x plus h whole square minus x square divided by h. Now you can apply the formula a plus b whole square. Limit h tends to 0 of a square x square plus 2ab 2hx plus y square, that is b square h square minus x square. A square plus 2ab plus b square minus x square plus x square gets cancelled. What is left in the numerator is 2hx plus h square. You can take h common factor, 2x plus h. So this h and h gets cancelled. Apply the limit. If put h is equal to 0, then this becomes 0. 2x plus 0. 2x plus 0 is equal to 2x. So therefore the derivative of this is nothing but, we can also write y dash or f dash x. Suppose if y is equal to x square, then this is y dash or dy by dx is equal to 2x. So differentiation of x square is equal to 2x. Now move on to the next problem. F of x is equal to 1 over x. Now since f of x plus h can be written as 1 over x plus h. What is the definition? F dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h. So this f dash of x can be written as limit h tends to 0, f of x plus h is 1 over x plus h minus f of x is 1 over x divided by h. Now in the numerator, just take LCM. H tends to 0 of, what is the LCM? X plus h into x is the LCM. X plus h into x. Now cross multiply. X into 1 is x minus x plus h whole divided by h in the denominator. So that is f dash of x is equal to limit h tends to 0 of, multiply it, x minus multiply by minus x minus into plus minus h divided by in the denominator x plus h into x, and take this to the numerator. This is 1 over h. Now cancel that terms. Minus x and plus x gets cancelled. This is limit h tends to 0 of minus h divided by x plus h into x into h. So this 2 gets cancelled. This is equal to limit h tends to 0 minus 1 over x into x plus h. So put h is equal to 0. If you put h is equal to 0, apply the limit. Put h is equal to 0 minus 1 over x into x plus 0. That is minus 1 over x into x. What is x into x? X square. So derivative of 1 by x is minus 1 by x square. So therefore f dash of x is equal to minus 1 by x square. That means d by dx of 1 by x, derivative of 1 over x is equal to minus 1 by x square. So derivative of 1 over x is minus 1 by x square. This is how we are going to differentiate the function using first principle method or by the method of definitions. Hope you followed. Very simple. Just consider the given function as f of x. F of x is 1 over x, and change x to x plus h. So wherever x, just put x plus h. This reduces to f of x plus h. F of x plus h is equal to 1 over x plus h. So according to the definition, what is the definition? F dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. Now f dash of x is equal to limit h tends to 0, f of x plus h is 1 over x plus h minus f of x is 1 over x divided by h. Now take LCM and simplify. What is the LCM? X plus h into x is LCM. Cross multiply x minus x plus h divided by h. Now multiply by negative sign. Minus x minus h. Minus x and minus plus x gets cancelled. Minus h divided by x plus h into x, and bring this to the numerator. Just this can also be written as 1 over h. So minus h divided by x plus h into x into h, cancel, h and h gets cancelled. What is left is minus 1 over x into x plus h, right? Now if you apply the limit, what happens? Minus 1 over x into, put h is equal to 0, x plus 0. X plus 0 is x. Minus 1 over x into x is x square. That means d by dx of 1 over x is minus 1 by x square. Okay, right. So therefore f dash of x is equal to minus 1 by x square. That is differentiation of 1 by x is minus 1 by x square. Hope you followed. So this is how we are going to differentiate any function using first principle method or by the method of a definition. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.